Alright, so first of all, let me tell you guys what this video is not going to be about, just to save you some time. This video is not going to be a step-by-step, straightforward guide on how to improve your Linux gaming performance. There are a lot of very good videos about that already, and I'm going to put some of them down below, so be sure to check them out if you're interested in, that kind of videos. This video is also not going to be about KVM pass-through and gaming in a virtual machine with your real, graphics card passed to Windows and a virtual machine. Unfortunately, I don't have an integrated GPU on my Ryzen machine, and I also don't have a second GPU kicking around. But if you do have two GPUs, maybe one for gaming and another one for the host operating system, just to draw the interface, this might be an optimal solution for you. And while yes, I am aware that single GPU pass-through is also a thing, but it requires you to shut down all the graphical applications and your X11 server in order to launch a virtual machine. And at this point, you might as well just dual boot because it will be less of a pain. But that being said, in this video we're only going to focus on the performance in Linux itself, be that native games or Windows games running through Wine. No virtual machine shenanigans today. Yeah. Alright, so about a couple of months ago, I made a video where I compared the gaming performance on Windows 10 AME and the vanilla Windows 10, and I also threw my Arch Linux installation in there. And what do you know, the Linux box actually showed some pretty good results. Now obviously these results were still a little bit worse than Windows, and some of you guys mentioned in the comments that there are some optimization tweaks and programs that actually help improve performance on Linux even further to kind of match it with Windows performance, especially for AMD graphics cards. Now unfortunately I don't have an AMD GPU, but that being said, we still have some things to try today, see if maybe some of those tweaks are going to improve the Linux gaming performance and maybe match it with the one of Windows. So here are the 5 optimization methods / tweaks that we're going to try today. First one, the most obvious one, is trying to switch to a more lightweight window manager / desktop environment. So instead of resource heavy and bloated GNOME, I am going to try to switch to Openbox today and run my games on that, see if that improves the situation at all. Next thing we're going to try today is Xanmod kernel. This is a custom Linux kernel that contains a bunch of optimizations, memory tweaks, resource allocation stuff, CPU. I'm not even going to pretend that I understand anything that's written on this page, but it should be good, so we're gonna try it. Feral's GameMode. Feral is a game developer that has developed games like Shadow of the Tomb Raider and Rise of the Tomb Raider. Both of those games run natively on Linux, and basically what GameMode does is it activates a bunch of gaming and performance centered optimizations on demand. So basically if you want to run a resource heavy application or a game, you can activate GameMode and it's supposed to run better. Feral's GameMode is also integrated into Feral's own games on Linux, such as already mentioned, Shadow of the Tomb Raider, and it's also integrated into apps like Lutris. So really the only game that we're going to be activating it for explicitly today is Doom Eternal. Last but not least, we're going to be trying Garuda's performance tweaks package in Arch Linux. Now Garuda is actually a gaming focused distro that is based on Arch, and I actually wanted to make a separate video about this distro on this channel, but after downloading it and trying it out, I couldn't really make a single game run on Wine, and the whole distro just felt unnecessarily bloated. Luckily we don't have to install the whole distro to try out the Garuda's performance tweaks because they're included as a separate package in Arch user repository. So that's what I'm going to install. Now I also want to talk about some caveats, some things that you maybe should keep in mind if you want to switch from Windows to Linux and you also want to run all your favorite games. First of all, NVIDIA's proprietary technologies such as ray tracing and DLSS are not going to work on Wine games. Now I know a lot of you guys will agree with me when I say that ray tracing is pretty much a gimmick. It looks cool, but it's not something that you would really notice in the game when you're just running around the map, and it pretty much cuts your performance in half. So this is not something I'm interested in, but DLSS on the other hand is a pretty cool thing. So for those of you who don't know, DLSS is a proprietary NVIDIA technology that renders your game at a lower resolution and then uses some machine learning AI dark magic shenanigans to upscale it and make it look like it was rendered at a native resolution. Now I know it doesn't sound like much, but actually it looks pretty convincing, and it can seriously improve performance on budget cards and on higher resolutions. Now because of the proprietary nature of those technologies, as I already mentioned, we're unlikely to see the implementation of them on Wine, at least in the foreseeable future. However, the support for DLSS 2.0 has been introduced into proprietary drivers for NVIDIA on Linux, so we might see the support for DLSS on native games, sometimes in the future. Now, the second thing that I want to mention is the fact that there is currently no way to undervolt the NVIDIA card on Linux. Now, once again, for the uninitiated, Undervolting is basically a process of editing your voltage curve for your GPU and making it run at the same frequency but at a lower voltage, which essentially gives you the same performance but makes your card run quieter, cooler, and consume less power. There's literally no reason why you wouldn't want to undervolt your card, whether you have NVIDIA or AMD GPU, but on Linux, when it comes to NVIDIA cards, this is just not an option. Now, there is an application on Linux that is called Green with Envy, which lets you overclock your card or change the power target, but it doesn't let you undervolt the card, so that's a shame. Now, the third thing might be obvious to some people, but I still want to mention it, and that's the fact that a lot of games are much harder to run on Linux than they are on Windows. Now, I know Linux gaming has come very far in the past decade, and a lot of games, especially Steam games, are very easy to launch. You just download the game, you click play, and it just works. It's magic, But at the same time, some games are still a pain in the ass, and they require you to tinker with different wine versions, wine tricks, Proton packages, etc. And if you take a look at Proton HQ or Wine HQ, which are, forum kind of websites where people discuss the compatibility issues for different games, you'll see a ton of reports of crashes, performance issues, glitches, games just not working at all, so it isn't all hunky-dory. Now, I don't want to discourage anyone from trying Linux, and I don't want to, trash talk about Wine developers or Linux developers, but at the same time, you have to have realistic expectations. If you come from Windows with this attitude that, you think everything will just work, like on Windows, you'll probably be very, very disappointed, so just keep that in mind. Alright, so let me tell you about my hardware and software setup, and then I'll show you the results. My desktop rig has undergone some significant upgrades and modifications. Yes, unfortunately, the pandemic hasn't really had a positive effect on my financial decisions. I'm running Ryzen 5900X with 32 gigs of RAM, running at 3600 MHz CL18, and an NVIDIA RTX 3080. Now, I know these CPUs and GPUs are, a meme because they're so hard to get, but if you know where to look and if you don't mind waiting a couple of weeks or months, you should be able to get them just fine. Now, some of you guys might say, well, what's the point of benchmarking such high-end hardware? Because, most of us don't have it. Well, don't worry, I'll be crippling my performance significantly by using a 4K monitor. So the FPS that I'm going to show you guys today is probably what you would get on a mid-range NVIDIA GPU from last generation on a 1080p monitor. When it comes to software side of things, I'm running Windows 10 20H1 deep loader with AIM-E scripts, just to have baseline performance to compare to. And as for my Linux setup, I'm running Arch Linux with the kernel version 5.10 and the latest proprietary NVIDIA drivers at the time of filming. Now, without further ado, let's get into the results. I'll be testing 3 games today. Shadow the Tomb Raider, because this game runs natively on Linux, Metro Exodus, because this game has a built-in benchmark which makes the results more consistent, and Doom Eternal, because it's a Vulkan game, and that way we can see how the tweaks affect those games that utilize Vulkan API. Let's start by establishing a baseline and comparing the FPS figures on Windows and Linux. Starting with Shadow of the Tomb Raider, on Windows we get 85 FPS on average and 75 FPS for 95%, and on Linux, well, shit, I guess my job here is done. The game already runs better on Linux than it does on Windows. Thank you for watching this video, and bye! Just kidding. We'll see if we can improve those figures even further by using some tweaks, but for now, let's move on to Wine games. On Metro Exodus benchmark, we get 72 FPS on average and 40 FPS for 1%, and on Linux we get 10 to 12 FPS lower with 65 FPS average and 30 FPS 1% figures. Pay attention to that second number because even though average FPS is a good way to assess overall performance, the percentile figures, sometimes they're called 1% or 99%, are a great way to see how smooth the gaming performance will be and whether there will be some stuttering. As you can see, on Linux we drop to 30 FPS, which can cause the experience to be less smooth than on Windows. Finally, on Doom Eternal on Windows, we get 171 FPS on average, as well as 109 FPS 1% figures, and running it on Linux, we once again lose some FPS, resulting in 146 FPS on average and 103 FPS for 1%. Not too bad, but there's definitely some room for improvement. So let's start by switching to Openbox, and here with Shadow of the Tomb Raider, we don't really see any improvement whatsoever. The FPS stays the same. On Metro Exodus, on the other hand, ditching GNOME gains us 2 additional FPS on average, which is nice, but the 1% figure remains the same. On Doom Eternal, switching to Openbox results in higher FPS on average but lower 1% figure. Do keep in mind though that Doom Eternal doesn't have a built-in benchmark, so I'm pretty much running around the same spot and capturing the FPS while I'm doing it. It's not ideal and we will see some inconsistent figures throughout this video. Next thing we're going to try is enabling game mode, and since Shadow of the Tomb Raider already has game mode built in and Lutris, which I'm using to launch Metro Exodus, also has it enabled by default, we won't see any performance improvement with those games. I tested them anyway just in case and it's the same, no improvements. On Doom Eternal, enabling game mode makes us lose some FPS compared to just running it in Openbox, but in turn increases 1% FPS figure, bringing it to the Windows level, which is nice. Now it's time for the Xanmod kernel, and I will say that on Arch Linux you need to compile it from sources. You'll also need to change some options in the package build file to optimize the build for your CPU. Xanmod kernel also includes the recent Vutex patches that enable F-Sync in Proton and Wine. This basically makes it so that the Windows games utilize your CPU more efficiently. You do need to enable F-Sync manually in Lutris, and you can also export this environment variable if you're launching your games in terminal. So, installing the Xanmod kernel improved our FPS in Shadow of the Tomb Raider by exactly 1 point, for both average and 95% figures. Not exactly the massive gains I expected, but whatever helps. We see no improvement in case of Metro Exodus, however, still the same 62 FPS on average and 30 FPS 1%. In Doom Eternal there is no improvement for the average FPS, but we get 4 more FPS in the 1% department, which finally elevates us from the Windows peasants. After installing all of these tweaks, you can finally say that the games run smoother on Linux. Well, some games anyway. Finally, I installed the Garuda performance tweaks package to see if we can improve our performance further, and that's where things took an unexpected turn. I had to switch to my ThinkPad with the internal graphics because the results on desktop were just too good. And after installing Garuda's performance tweaks on my laptop, I was now able to play Cyberpunk at 60 FPS in 1440p. No, just kidding. Installing the performance tweaks package actually made the results worse, especially in percentile figures. We lost 1% in Shadow of the Tomb Raider, and things only went downhill from there, with 1 FPS less once again in Doom Eternal and 2 additional FPS lost in the 1% figure in Metro Exodus. I couldn't believe my eyes, so I uninstalled the package and tested the games again, and yep, the results went back to normal. So if anything, some tweaks that are supposed to improve your gaming performance actually make it worse. And here are the final results. By installing all of the aforementioned tweaks, we gained 1 additional FPS in Shadow of the Tomb Raider, but the performance was already pretty impressive to begin with, and definitely nothing to scoff at. In Doom Eternal, installing the tweaks got us a 10 to 13 FPS improvement. Once again, nothing groundbreaking or game-changing, pun intended, but we did get our 1% figure to be higher than on Windows, which is nice. Finally, in Metro Exodus, all of the optimizations and tweaks got us 2 FPS improvement for our average figure, and no improvement whatsoever for the 1% number. To be honest, I'm a bit disappointed by the results. I don't know what I was expecting, but I kind of secretly hoped that throwing all of those optimizations at my Linux installation will give me like 20 more FPS on average. That being said, your mileage may vary, and maybe on your hardware those tweaks will net you better results, so keep that in mind. So yeah, this was a pretty disappointing video to make. You know, I have wasted a lot of time that I could otherwise spend laying in my bed, wallowing in self-pity, consuming German beer. But nevertheless, thank you guys for sticking around, and as usual, I want to thank my patrons: Ray Peria, Devin Merrill, Mitchell Valentino, and Tim with the Grog avatar. Thank you, Tim, for joining in. So yeah, thank you guys a bunch for watching this video, and I'll see you in the next one. Goodbye.